Right. All right. So today, as I said, this is our last lesson about talking about Python as like the ultimate desk calculator here. So revel in it. We're going to actually start programming the next time. I really wanted to actually get you writing serious programs today. I don't think it's going to happen though. But we do have some fun. We have a lot of fun for you today. Basically, we're going to do more things about manipulating strings. Oh, look, I have this. Perfect. Look, look at this. My best stick yet. We're going to do more things involving manipulating strings, putting together string items. Then we're going to go to particularly Lippy brought this up, and it's true. I'm not doing you a service by not teaching about files. Particularly, it's dead easy in Python. It's the easiest damn thing. You will plot. So we're going to do files, a bunch of files. That's probably going to take quite a reasonable amount of time, but it's all pretty easy. And then we're going to spend the rest of the class talking about the Python runtime library and a whole bunch of cool things involving that. At the end of this class, you will actually be able to do interesting things like chores and things that you might want to do. So you actually will get somewhere. You'll actually be able to use this aside from just adding up your household expenses or whatever the hell you do, which you shouldn't be doing in Python anyway. Use a spreadsheet. Okay, so let's go back to our tabular browser. Oh, and this is, as somebody else pointed out, what do I do all my work in Terminal? No, I do none of my work in Terminal, but the Terminal is really handy for doing quick demos like this. Next time we'll probably do it all in PyCharm. Yes?
PyCharm just bogs down my computer, so is it okay if I use
Any editor is fine. I picked PyCharm because it works and it's very Python oriented. I don't use it actually. I'm going to have to learn it next time. I use Emacs. Now Emacs is this. I love it. Does everything, but it's a little bit complex. If you saw my initial installation notes, I actually had you installing Emacs. It's kind of like the ultra editor for programmers, but at the same time people complain. It's got way too much stuff in it. It's got everything. I mean, what's this? You can check your email, you can do news groups, you can run a shell. There are multiple games built into this thing. An adventure game that's really entertaining. There's a thing called Butterfly that randomly perturbs one byte in any of the files you have open every few seconds. Like it does a picture of a butterfly and it says, okay, I've changed one character in one of your files. That's really useful. I don't use that. And it's got editing modes for everything. You can open files on a remote machine like they're local. It's fantastic. It's too complicated for most people. So that's why I picked PyCharm. Any editor will be great. I may even end up using Emacs itself because I'm just so familiar with it compared to everything else. So yeah, there's no specific editor you need. You won't need 98% of what PyCharm does. It does all sorts of great things. It even hooks up to the App Engine, but you don't really need too much work to hook up to the App Engine. So any editor you need, and if you need my help with picking an editor or setting up an editor or whatever it is, hit me up. This is one of my insecurities in this whole thing because of, you can't use Word. I should add, things like Word and such, they won't work. The reason is they're not storing things in pure text. They have text with all of this crap, the underline, the italics, the bolding, all this stuff. All of that information is in the document, so if you try and run it as Python, Python will quite rightfully stick up on it, or any programming language. So you need usually you have what's called a programmer's editor, and there's a whole bunch. There's PyCharm, Sublime Text, a lot of people seem to like that one, Emacs, this thing called VI or Vim, that's kind of, the Emacs people and the VI people have this 40-year long-standing war. Oh, you're a VI person? You learn these things about your friends and it's just embarrassing. It's all right, John. At the end of this class, it's a long-standing thing. So, right. So, particularly before the next class, you should find an editor you can live with. That's either a pure text editor or a programmer's editor, and figure it out. If PyCharm, I haven't tried it on an older machine. Oh, this isn't that new. You can tell, look, it's old.
It was just hanging at certain points.
Hanging?
Well, it's like it would say processing, and then it wouldn't do anything, and then when I looked at the activity monitor...
Yeah, that's hanging, right? I mean, I knew I know, well, that sucks. I mean, it's brand new, fresh. I mean, this is a great company, JetBrains. They do like this amazing Java editor. They're supposed to come out with a C++ editor.
I have a little experience with programming and sort of editors. So if I can pick something.
Yeah, pick whatever editor you like. I'm absolutely not prescribing an editor. So there we go. Question?
I've always been confused. What's like the difference between something like Notepad++ and VIM?
Well, I'm not sure. Okay, I guess I don't know, but I think Notepad is actually a pure text editor, so there's not much difference.
Yeah.
You just really want something that doesn't let you put stuff.
What exactly does VIM do?
It's a text editor that runs everywhere. Plus, the big difference is everybody calls it Vim. Vim's kind of a descendant of VI. VI stands for visual something or other. But they're all designed to work on a terminal, pure terminal like this.
Oh, okay.
Right? You see, whereas Notepad++ is a Windows program. It only works on Windows. But VI and Emacs now, of course, now both VI or Vim and Emacs have full GUI things. But the nice thing is, once you learn them, I do a lot of my editing right on the server. Probably a bad idea, but I get away with it. And you can do this because of the fact you can run these editors remotely on another machine and see them on your local machine, because it's just sending character commands. If you were actually sending instructions to actually draw little pixels, it would be so slow you would die.
I mean, there's another big aspect in my experience is just that there's stuff that you don't, like footnotes or whatever, those are things that you do when you're composing documents, but in code you're going to a line, or you're automatically trying to select an entire paragraph because that happens to be an entire function which you're going to move somewhere else, or so there's these things that you end up doing, like selecting a line
or like indenting everything, for example. A classic thing you need to do in Python is you say, oh, I want to put this inside an if statement, these 20 lines, so they all have to indent. And something like Emacs has a command that says indent this whole area, you know? That's really handy. Or any text, you know, PyCharm, any of these programmers editors. So yeah, what he said, basically. All right. I'm not trying to cut you off. Any more questions? Right. So let's get on to fun with strings. So let's start off with a couple of things which I kind of felt I should have taught you before, but it's not clear where I would fit them in. These are these two useful things called split and join. And particularly, we're going to be making great use, you make use of these all the time in Python, and you're going to be making a great deal of use of them in the coming weeks, because we're doing a lot of things involving text. Split is a way to take a string and split it in, guess that, split it into a list of strings. And let me just show you, hello world, how are you? And we do dot split, space, and oh dear, right, I need, this time we're going to use for the spot, Eve, you're on the spot, with a drumstick. Is that good?
It's fine.
Good.
Just want to make sure roll it.
Yeah, thanks. After the debacle last time. So Eve, guess what is this going to do?
Will it split it on the space?
You have it. Splits it into a list of strings. Very, very handy. And you can do, you know, you can do all sorts of things. Notice, however, for example, if you do, forgotten your name, damn it.
Amanda.
Big one?
Amanda.
Amanda, and it's Pickering even, yes. Such an Anglo-Saxon name, you've got this. So guess here, what do you think this is going to do if I do comma space?
There's no commas. So...
Well, there's one comma. I put a comma in, sorry.
Oh yeah, so I'd probably do a list of hello world and another how are you.
That's very good. Excellent. I was trying to trick you, but you've... now, sometimes you want to actually split that. Sometimes you want to actually split, you would want to actually split this into words, where you say, okay, no, comma, space, space, whatever. Now, this deals with something called regular expressions. I'm still split as to whether we're going to teach you regular expressions or not in this course. There's an old proverb that says, or some wit in the computer science field says, you have a problem you wish to solve. You decide to use regular expressions. Now you have two problems. Because regular expressions are very tricky, they're easy to shoot yourself in the foot, it's easy to get them almost right. What is a way of doing complicated pattern matching? That said, they're really useful, particularly if you don't go hog wild. I may or may not teach them to you, but I'm not going to do it today. But suffice to say, there is a way if you want to split more complicated things. We're not going to get into that today. Split's straightforward enough. Let me try. Let's do some more guessing here. Supposing I split now on the empty string. John, what do you think it's going to do? Guess. Remember when I said guess, you all try to guess in your
I'm gonna
head.
guess it's the entirety of it.
You might guess so, but it's not true. It doesn't let you do it.
Oh,
That's interesting.
Yes. And you're like, supposing you wanted to, you're like, well, wait a second, what if I wanted to split the string into its component characters?
Right.
Why couldn't I do that? That's what I when I was experimenting for this, I expected to do that. But in fact this was an exercise in I think this class, the most recent exercise. So can anybody? I'll throw this open to the whole group here. Can anybody guess how I would split this into a list of its individual characters? It was in the exercises.
Slices?
But that's going to give you one long string.
Oh.
So slice. Anyone? Well, easy enough. List. If you take list here, it gives you a list of the individual characters. And remember, a list of anything, a list of any iterable item, anything that's iterable, if you remember that concept from last time, something that has a succession of elements in it, we'll take a list out of each of those things. And the string is iterable through the characters, so there we go. All right, so corresponding to split, there's a join. Now, I'm going to explain, the syntax for join is not what you'd expect. Let's do a nice split here. Let's do s equals this. So join is the reverse of split, not what you expect. We say space dot join s, and now you've got the stick. What do you think it's going to do? So we split s up. Let's print it, and then we do s dot join space. What do you think this is going to do? Oh, you see, I get this wrong almost every time. Space dot join s. What do you think it's going to do?
It's so. I mean,
Guess.
I think it's going to put the sentence back to where it was.
You got it right. So the question is, why is it space dot join? Right? Why isn't it s dot join space?
Okay.
No, it's not even a question. It's a guess. Anybody get a guess? I've forgotten your name too.
Oh, Ray.
Ray. Okay, thank you.
I think that's like the same thing. So isn't that how you sort of apply classes or modules? Like you're doing something to that open-ended string that you do first.
Kind of, but you could do it either way. I mean, there's no.
And you're sort of calling the join function onto that open-ended string and using s as a parameter. That would be how I would.
That's true, but you could reverse the argument. You could make the same argument for spaces. No, it's simpler than this is. Join works on any iterable thing whatsoever. So you can join a list, you can join a tuple, you can join a generator, you can even potentially join. Oh, let me go. One of ours?
Oh, yeah.
Hello, Brian. Oh. Good time.
Thanks.
Yes. You see, you'll be that interruption immortalized on the internet. 1,000 years from now, they'll look in and see this.
You were the.
Yeah, I doubt it. Oh, yes. Tom.
The first line.
Yes, sir.
How are you before split?
Yeah.
Is that a period or comma?
That is a period. Period.
I tried both and I keep getting an error, empty separator.
There needs to be a space between. So in the first one here, you see the difference in this is there's a space between those two quotes. Here there is not. There you'll get the empty separator. So there it's single quote space single quote. And usually Python. One second. Python's error messages are generally pretty good. If you take a look, it says empty separator. You're like, oh, well, what's the separator? Oh, it's empty, so it's not so bad. John.
If you use an empty separator for the join, does that just go in?
Good question. Let's take a look. Who's got the stick? You do. What do you think it's going to do? Just throw a guess out. You don't have to. It's a guess, right?
Error?
No. In fact, it glues it all together with just empty line. In fact, you do that. But you do that there all the time. You break things up, including the spaces. You put them together all the time. So join and split are 100% symmetrical, right? You see, you can split. You can't split on an empty string. but you can split, you can join on an empty string. Is that good, John? You're looking a bit puzzled?
No, I get it, because now I see that you have a list there, and that's how you would go about cutting it apart into the individual elements.
Right.
Okay.
You're also calling it two different ways, aren't you?
Right, you're calling it two different ways. You're actually calling, the join is, the split is an operation on the string, whereas the join is an operation on the join.
How would the
Oh, I
join look if you were doing it the same way that you called the split?
These two parameters,
Yeah.
my hand makes a good pointer. These two parameters would reverse, but I'm not going to show it to you because it won't work.
Okay. Good enough.
So, fair enough, is. Okay, so these are pretty straightforward, and again, is when we get to regular expression, there's no regular expression version of join, but there's a regular expression version of split that will handle a lot of fancynesses. Alright, so straightforward enough, but this isn't really going to do it when you're putting out fancy messages. It's going to be very, very annoying if you have to do things with plus signs. Oh, and I'm sorry, I did want to mention something. Here's a little fanciness that you should know is, sometimes you're tempted to do something where you add together a lot of strings. Particularly, you may do something like that, or you may be doing it in a loop. You may say, for I in, let's say, S is an empty string, for I in range 40, S plus equals string I. I'm getting this right. All right, that seemed to work. And when we get this long string with all those numbers in it, okay, it turns out to be actually kind of pathologically inefficient. So I'm noting this for you for now, kind of just to improve your general knowledge, because in the sorts of things you're going to do, you probably won't notice a difference. But the reason this is inefficient is this has to build 40 separate strings when it's doing this. You could work out, if you knew all the separate strings, you could work out the length of the total string and put everything into it. But what it has to do here is it starts off with this empty string, then creates a new string with 0 in it, then a new string with 0, 1, and a new string with 0, 1, 2. Every time you do it, you copy all the values of all the previous strings. It turns out that the speed at which this executes, or the time it takes this to execute, this particular thing, is proportional to the square of this number 40. The square of 40 here. So if you had a 10,000, it would be extremely time consuming. So when you're tempted to glue together strings in a list, don't do it. In a loop, sorry. When you're tempted to glue together strings in a loop, do not do that. No. Bad mistake. It turned out like Google ran into this with some stuff. And you would think, here are these people who are like super smart and things, but people hadn't realized this. And one of their big jobs would just slow down magically, periodically, because it turned out sometimes they were doing something like this and gluing together a lot of strings, and it took the square of 10,000 entries, which is 100 million. So don't do this, use join. That's one of the big reasons join exists. That's one of the big reasons every computer programming language has a join, a modern language has a join, is because of this hidden trap that this thing, the time this takes is proportional to the square of this number, which isn't obvious. You would say, oh, if I made that 80, it would be twice as long, but no, it's going to be 4 times as long. So in computer programming, we call this quadratic. It's quadratic time. And yes?
No, I'm just wondering how you would do that without...
Very good question. Everybody's got good questions today. Let's do it. Here we go. We've got, so let's start with the string, and we say for I in range 40. That's fine. And then we say s dot append string I, right? So, and then we say, so s is now this thing, and then we do quote dot join s. So we use the join function, remember, right? And then we get that. That's why I said we're going to do joins a lot on empty strings, because this little mechanism you see there is very, very common. Now, in fact, who's got the stick? So there's a better way to do this. It's a question, Ethan. There's a better way to do what I just did. What is that?
I don't know.
We did a little bit of it in the exercises. Something we learned last week. Well, whenever you see a loop that's appending to a list, what should you think? Generally, you should be thinking of a list comprehension. list comprehension. Don't worry, your instincts will get much better. And as I said, I review a lot of people's code. It astonishes me how many times I see somebody do something in a loop. I'm like, dude, you've been doing this for 10 years, you should know. So let's actually do it as a list comprehension just to, just to get warmed up here. So how would you do this? You would say something like, I'm going to start with the join, and then I'm going to say stri for I in range 40, and that better do the right thing. Look at that, got it right in one. So you can see it's a lot shorter way to do things. I could keep, by the way, quick question here. I keep all of this. Would you like me to just paste all this into a document for you? Put it up? Would that be of use? All the interactions I have?
Yeah.
Yes.
Sure.
Yeah, good. Can't hurt. I'll do that. Of course, I can do the last 2 lessons even, because I kept the last one. Right. So there we go. So you find yourself doing this sort of operation. So this is kind of the way to do it in a sort of idiomatic Pythonic fashion, right? You can see that the other one is 4 lines, and this is 1. And plus this actually turns out to be more efficient. Because it doesn't actually, if you look, in fact it's what I'm not doing. I'm not even doing a list comprehension, I'm doing a generator. If you call the generator version, it doesn't actually compute the values till you need it. So it's always a bit more efficient. So, just a note here. But so, popping back to where I was before, while joins and things are pretty good for this sort of automated thing, they're not good for what you're going to be doing a great deal of, which is building text messages to print to other people. All the time in the world you want to print something like, there were 5, you got 5 answers, or, the answer is Joe, or this sort of thing is. So there's Python actually has 2 ways to do this, unfortunately, but they're both pretty good, they're both pretty straightforward and easy. And they had the original one that dates from Python 1.0, and then later years they came up with a separate version. So the first one is called the percent operator. The second one is called string.format. And they first they did the percent operator, it's pretty cool and very easy. Then they came up with string.format, that's not too much more difficult, then they said, oh, we're going to try and get rid of the percent. Everybody's like, no, percent's really easy. I have in thousands of places in my code, we're keeping that. So they have both. Neither of them is too difficult. So the answer is %s, silly. Okay. Who's on the spot right now? It is 23. Who's on the spot? Guess. What's this going to do if I press return?
The answer is 23, so...
Right. And it's very, very straightforward. It just puts in whatever's in %s is replaced by your argument. And you can have multiple things. %s, not %s. And there we have to use either a list or a tuple, so not 30. And question, what do you think this next one does?
It dumps 23 into the first format character and then 32 into the second.
Right. So the answer is 23, not 32. Silly. So you may be wondering why %s. Well, nobody did ask that, but it's %s is for string. There's a string input. Now, the nice thing about Python is it's pretty, as I said, it does what you expect. Even if I put in even if I put numbers in there instead of characters, you're going to get the same answer. I'm not going to bother to ask this. You'll get the same answer because Python automatically converts those integers to strings. So you're like, well, what's the point of this? Well, what you can do is that there are other formats that you might conceivably want to use. One of them is D for a decimal number. I hope I'm getting this right. So, right? And you're like, well, what's the difference here? Well, for one thing is this won't work if I have something like foo and bar. I get an error. Right? Oh, %D format. A number is required, not a string. Again, a pretty nice thing. So that's actually like, oh, why would I want to cause errors? Well, you want to cause errors because if you want that to be a number at that point in your program, and it isn't, you need to know this fact. You want it to fail. There's other reasons. You may want to do something like the following. You may want to format some long, complicated number. So you may say something like 2.1D, not D, silly. So then we may have something like, actually no. So let's do 10 point something here, and then 20. Maybe it's, well, I forgot, I should have studied this before I started. Let's try this. All right, I'll get back to you on that one.
Well, you would have to use percentile R to get the decimal input, right?
Let's find out.
Or you have to use percentile F.
Oh, probably percent F, that's right. That's right. Wah, wah. That's right. So 2.1 F, yes, absolutely right. F is the correct one. So basically it also gives you the ability to do formatting. That's what it comes down to. Sorry if you're getting confused there. And if you, let's go back to the original one here, where I have D, and let's just make it something like 10. I can do something like, fit it, if supposing I want to fit something into 10 characters, I can put 10 there, and you see it actually fills things out for 10 characters. That's really handy when you're printing boring reports and doing boring tablature and boring things involving financial statistics, when you want everything to line up. So this kind of a quick show through this, but basically is, if it's pretty good for this sort of thing. You'll find most people's Python code uses this percent notation all the time. In fact, literally what I was working on yesterday, I was doing this with a huge number of error messages. But there are drawbacks. One of the drawbacks is that the order that the things appear in the string is the same that the order that they appear in the arguments. So always that first percent corresponds to the first argument, the second percent corresponds to the second argument. Like, well, why is this a trouble? Well, it could be that that format string you have appears in multiple languages. And if it appears in multiple languages, the order of the words may appear differently. Right? So in other words, in English, English you get is a subject, verb, object languages. There are other languages that are subject, object, verb languages. German sometimes does that. Japanese, I think, is Japanese is, anybody know? Anyway, it's not subject, object, verb. So the word order changes. So if you have translations of your program where you have, the answer is X, Y. In another language, if it's Y, X, how do you deal with that? You can't do it with this. There's also things where you may have like lots and lots of strings. You may have a big long thing with many strings, and trying to keep them by order could be really, really difficult. Suppose you have a whole web page, you want to fill tiny bits in. Trying to, this is parameter 5, it's going to be really, really hard to understand. So what we have is we have string.format. And I'm going to go to the help page for this, which I probably should have gotten up for you. Python string format. Let's take a look. Let's see how quickly I can find it. Here we go. Format specification mini language. So it's pretty, like all of these things, it's a huge, huge document here, most of which you don't have to see. And the nice part about this is it actually lets you specify, and I should add one more terrible downside of the percent thing is you can't repeat any of the parameters. If you need to say the same thing in 4 places, you have to repeat it in the arguments 4 times, which is really bad. So string format is pretty straightforward. You do something like, let's give an example. %0 is, that's not percent, what is that thing? Brace 0, dot format 1232. Let's hope I got this right. Right. So, straightforwardly enough, you can everything inside these brace brackets refers to the index in your arguments. But unlike the other case, you can do something like this without changing the inputs. Right. So in case you're speaking Japanese or whatever it is, so very straightforward. But there's other things you can do, which are really very nice. You can have named parameters. So you can say something like toads, me is you here, and then I can say something like this, where I go, me equals Tom. Oh, no, that has to be quote. Tom.
I want to make sure
you equals. Can I get you to keep it down a bit? Sorry. Can I get you to keep it down a bit? Sorry. You equals. Who haven't I picked on? Dahoud. I haven't picked on him today. Right. So right, and so it actually fills in the slots. So that's really handy this is very, very handy for big things like you have a big web page, you want to fill a tiny bit in. You don't have to, you can just actually put in when you write it, you say, okay, I'm going to fill in this value, like date. And then later on you say, okay, when you're passing the thing, you say, oh, date equals this value. You don't have to get them in order. It's a much better way to go. There's a huge number of ways, clever things to do with the format. And I'm not going to go into them in this class. Yes, sorry, question.
Is that like syntax have to be specific? Can there be white space, or does it not matter?
No. There's in what was supposed to be 2 lessons ago, we still haven't got to. There's a lesson on keeping it clean, where we go through a lot of formal things you need to do. Basically, there's something what you call PEP8. And what PEP, I don't know what it stands for, Python something. But this is a list of kind of like not even pronouncements, but guidance for how to use Python. And you can tell PEP8 very, very early is this sets out the formatting that all Python programs are asked to use. It works fine if you don't do it. So I'm showing everything to you in PEP8. Right, all this format. So you notice here, for example, one of the classic things is, for example, I always put a space after a comma. It's never required. I always do it. I notice I put, let me scroll back here. Oh no, that's not how to scroll back. What do I have in equals here? Here we go. You can see that when I have an equals there, these equals, I put spaces around it when it's assignment. But when I'm passing it parameters, I do not put spaces around the equals. There's a reason for this, which I won't go into, but you don't have to worry because you can put spaces or not and it'll all still work. There's an advantage to this, mind you, is because most people use PEP8, if you read people's code, it looks just like yours. Big advantage. I had not really understood the advantage of this until I came to work at Google, when they had a huge code base, all of which looked exactly the same. And having worked in these other places where they had all this code, and when you go to read a new person's code, it's unreadable because they have their own, not unreadable, it's jarring. So it's like, oh, it's like reading this book. Imagine reading a book where every page was in a different font. You'd go crazy. You had a question?
When you're assigning variables within a format string like that, are those variables then set local to that line? Or
that is correct. They're not global variables. In fact, it's theoretically in this class, if we had had time, we would have gone into like how argument passing and things work. We may have a few minutes at the end. I hope to get into it because it's really fun and exciting. And again, it goes back to the everything is a dictionary thing. Everything's a dictionary. But yes, these variables. In fact, we can try it out. Let's take a look. If we do this, who's got the stick? You do. So what do you think is going to happen? So we had me equals you, and there's me getting assigned. What's going to happen when you type me? Now, error is not defined. It's only, as you surmise, it's only defined local to these to here. So it only has within the format statement. You don't even get to see within the format statement. It has values, but no, these are all local. Thank goodness. Life would be miserable otherwise. You'd be constantly stepping on things. And as I was starting to say, is there's an awful lot more to be done with that format statement. And there's pages and pages on it. And you're going to learn more of this in the exercises. I'll give you some exercises to work on this. But like a lot of these things, don't get overwhelmed by the fact there's like 5 or 6 pages on this. You know how it works now, that there's a way to substitute things in there. When you need something, you will find it out. And hopefully you will approach it without fear. And because it's not so difficult. So, but it's important to understand that if you're doing any real work, you're going to have to use some templating system to do this. There are other more, this isn't the only one, by the way. There's huge quantities of things. If you've seen things like Django uses its own templating system, if any of you heard of what this is. Not the guitars. Named after the guitars. There's another one there I had to do yesterday called Jinja. Jinja. That's another templating system. All of these things are something like this system where you substitute into a string values that you put in. Don't get freaked out by any of them. There's a whole bunch of them. They're all kind of similar. They have their own purposes. And I won't say too much more about it. But now, let's just check to see I didn't miss something here. Oh, right. Good, I'm glad I did check. Okay, we're getting into files. Now, files are one of the, actually, let me pop, okay, I hate to do this, but I'm gonna pop up Emacs to make my life easier. Here is, okay, voila. So, you can see what the heck I'm doing. I don't even know what I'm doing here. I mean, I know what I'm doing. I don't know what I was doing on this page here. All right, so let's do, I'm gonna actually start off, let's go to a shell somewhere, and I'm gonna, let's edit a file here. We'll call it tom.txt. Oh, sorry.
Could you bump the file size or the font size up a bit?
Yes, sir. Supposedly. Thank you. Yeah, and look, all of you were sitting there and now, hey, how you doing? All of you guys were sitting there, and none of you said this except him. You should, if you can't see, you should definitely say this. Except, it's supposed to be a way. I'm so sorry about this. View. Command plus doesn't work. Oh, that's because I'm in here. That's why. Try this. How's that? Better? Good? Okay, so let me do, I'm going to actually find a file. I'm going to call it tom.txt, and we'll say, hello there, this is a file. Not very interesting. Not very interesting. All right, so wanting to process files is something you're endlessly doing all the time, for both interesting things and boring things. No matter who it is, they're going to make you want to process a file. Luckily, Python really has this down. It's just, as I said, it's the ultimate desk calculator. Oh, that's funny. I guess it's per buffer. There we go. I'm going to make this one size smaller. Okay, so first let's just do this in one line. I'm going to say open tom.txt .read. Voila. So I got the file, all the values, and one thing. Oh, wait a second, though. What are those \ns? Good question. Who's got the stick? Do you remember those from before?
No.
Go ahead. Yeah. What the hell? Oh, well, we're gonna get this. Right. They're new line. N for new line.
That's like the code that automatically gets done when you're using like a word processor or something, right?
Yeah, I mean yes, and word processors have other hidden codes in it. Yes, but it indicates the end of line. Now, I should add that there's a little bit of an unpleasantness here because there's two types of computers when it comes to line endings: Windows and everything else. Windows, for some inscrutable reason I do not understand, have line feed carriage return, or carriage return line feed instead of one character for the end of character. It's ridiculous. So Python deals with this for you pretty well, at a slight cost, I should say. I'm going to I'll write that up for you. I'm not going to bother explaining it to you, except just to remember that if you're not on a Windows machine and your code will run on a Windows machine, you have to do a little bit extra to deal with those poor benighted souls who live on Windows machines. All right, so what's going on here? Let's go back to this thing here. There's actually two steps going on here. The first thing we do is we actually open the file, and why am I doing all this work? Right? So let's say F, classically F for file. All right, and what is file? Let's take a look at the type of this file. It is a thing of type file. What a surprise. And it has a bunch of operations on it. Quite a lot, as usual. And remember, we haven't talked about those. Remember those ones at the underscore? Those are all, they're literally called magic methods. Magic methods. And we still haven't dealt with those yet, mainly because they're not necessarily interesting to you at this stage. But we have a whole bunch of useful things here. Particularly, we have read, and we also have read line. So let's try. Hey, Howard, you can walk through. No singing now. There's a whole bunch of these things. Some of these are really, really handy. Again, you can look these up when you need it. For the moment, we're going to do simple things like read line, and this sort of thing. So you saw what we did before with read. So let's do f.read, and you can see we get this out there. So what happens if I do f.read again? Who's got the stick? What do you think is going to happen?
Same thing.
Nothing. The reason is that it reads to the end. It reads. You're actually opening the file, and having a little cursor pointing to the file, something in the file. So when you do read, it just goes all the way through, grabs everything, throws it at you, it's sitting at the end of the file. And you can, the reason that you have this is, it would make no sense, it would make no sense to do it that way if you always just read a file in. But often you don't want to do that. I mean, particularly in the old days when we didn't have much memory, you never read a file into memory. That was ridiculous. You'd read one line, process it, write it out. These days, actually, almost everything I do, I just read the file in memory, process it in memory, throw it back out. Because we have a huge amount of memory now. I don't know what, but I'll bet you none of these computers has less than a gig of memory on it. 1 billion characters. You don't type that fast. So, a lot of these things are kind of old school, but I still found myself opening pretty large files, just to read through. So the other way, so if I wanted to read this file again, if I wanted to get the value back, I would have to open the file again to get it. Now when I do read, if I do f.read, now I'll get the characters back again, right? John?
Is there a close statement or something?
That's a very good question. There probably is a close statement.
Yeah.
Let's just take a look. Is it in here? There it is. There is a closed statement. So why am I getting by without closing the file?
Because when you open it again, it's just like a tape machine. You're just like rewinding it.
Oh, that's true. But it's a good question that if I could open a file twice. I could probably open a file twice, but you can't open files for reading and writing. But it's actually even more straightforward than that. I mean, what you're saying is true, actually.
In read or write mode, I know that.
Yeah, I mean, once you get something in write mode, it actually in some systems it will lock the file so you can't read it. But but one of the things that happens is, and we'll go into this more, is there's a concept of what's called garbage collection. It's a huge area. Luckily, one of the nice things about Python is you don't have to learn about this. It's all done for you. But here's the thing: when you do something like open a file, it's actually using a lot of resources. It's like allocating a bunch of resources, and it's keeping them. Well, how do you prevent those resources from being wasted? Well, in some languages like C++, which I keep mentioning is kind of an alternative there, you have to keep track of memory. When you are finished with memory, you have to say, operating system, I am done with this memory, you can have it back. If you don't do this, the operating system never knows you're finished with the memory. This is called a memory leak. Eventually you run out of memory. Because you have all this memory that you are not using, the operating system does not know you're not using it. Every time you ask for more memory, it just gives you more. It doesn't reuse the stuff you had. Python has what's called garbage collection. When you finish using a variable, when you delete a variable, or when a variable has got a new value, all of the stuff is cleaned up magically for you behind the scenes. So when I do something like, let's do this again, the open thing. When I do something like this one-line thing, if I do something like this, it creates a temporary variable with just an open file, reads, gets the value, and then at the end of this thing, it just throws away, cleans up all that information for you, and that includes closing the file up for you. I actually had in the plans today to actually show you something. There's actually a statement, a with statement that cleans everything. Is very, very careful to clean everything up for you exactly when you want. I thought I was going to teach it today, but I decided in the taxi on the way over that I was not going to teach you because it's more appropriate for programs. Yes?
It flew out of my head, forget it.
Not to worry. It's that
It'll come.
short-term memory loss happens to all of us. Okay. So, but let's go try a few more things that you probably might never need, but it's nice to do. Let's do something like f. Let's do it. Let's just open this file again. Now let's do f.readLines. Who's got the stick? Guess, what do you think it's going to do?
Each line gets read out separately?
That's right, and what's the result going to be, do you think?
A list of strings?
That is right, we get a list of strings. You notice that you notice a couple points here. It includes the end of line marker. An empty line is a single end of line.
I remembered my question.
Yes.
When you originally opened tom.txt,
Yes, sir.
and a bunch of stuff came out,
Right.
and then you ran it again, and nothing came out.
Right.
I thought you said that after each line has been, taken care of, it closes whatever files have already been opened.
That's true. Well, that's true. The garbage collector goes off, but look what I did. I didn't actually. When I do the one-line case, so let's do delete F just to make sure. There's two things here. Here, when I do this, at the end of this, there's nothing keeping track of that file, right? There's nothing. There's no global variable assigned. In other words, I haven't saved anything. So it opens the file, dumps it to the terminal, and then at that point, garbage collects everything. Now, on the other hand, if I go and do this here, now if you take a look at this, it's actually got this file open in memory. It's actually keeping this, and you may wish to do further things with it. For example, you can do something like for I in F, print I, and it prints the file.
When you assign, like you just did there, like opening a file, and you assign that to a variable like f.
Yeah.
What happens if you do something like f+4 then?
I'll show you in 2 seconds. Wait, who's got the sticky spot? Didn't you just answer the last one, or did you?
I don't remember.
Oh.
It doesn't matter. It's all started.
So that's a very good question. So principle of least surprise. Remember we had that principle of least surprise that we hope to do everything happens. So we have a file. What would F, right? Let's make sure it's a file. The type of the thing is F. So what do you think is going to happen? Least surprise.
It's going to be an error. 'Cause
Yeah.
you're combining two
Absolutely.
things that don't-
Absolutely. So there's no, it's not a lot.
Stops you.
Yeah, it just stops you from doing it, which is very nice. And again, so here we just read this thing. Let's if we do f.read lines now. Again, we just get empty string there. All very. What's this? Empty list. What? I'm sorry. What'd you say?
No.
Oh, okay. Empty list. All very straightforward. Now the advantage to being able to do it like bit at a time, of course, is the file may be super huge. You may only want to have a tiny bit in memory at one time. I advise you, don't bother. Just bring it all in memory, manipulate it with the tools you have, drop it all out again at the end. Much easier. One day you will run into that situation where you have a 4 gigabyte file that you want to manipulate, and you will know that you need to do this, and you'll look it up. It's not really worth the energy of doing this. But let's go a little bit further into file manipulation. Now open, actually, I'm kind of cheating on the open because it turns out that, to be fair, you should actually open it with a bit more information here. Firstly, there's a second parameter, and the second parameter says how you're going to open the file. So really, the open I had before is actually saying open this file for reading, So I'll bet you can guess if I want to open a file for writing how it's going to go. So let's do this. Let's go. Let's say who haven't I? Let's do that. I haven't bugged him in a bit. Let's do n. Is open that.text. We're going to open this. So who's got the stick? Perfect. What do you think I'm going to type here when I want to write to that file? W. Very good. So we have a file, and it looks like the same thing. It looks very much. N. It looks very much like the same thing. It's actually the same class. All it is it's open. It's actually open for write. It's very, very easy to write to a file. I can just say n.write hello world n.write closing backslash, and then we're going to do n.close, which you don't even necessarily have to do. And then if we take a look here, ignore this part, it's just me using my edit, we can see, voila, I've just created a file with one line with a character return in it. Very, very easy to do. And you can often do it like, again, you can do it in you can do a one-line thing where you say, here we go.
Great guy.
Dot write, this is 2 strings, write you are. And then if I look at this file again, voila, it has just changed to something else. Yes?
I remember there's like some kind of pitfall with write code where sometimes you can overwrite over a file if you're not careful.
I just did.
That's essentially what you're doing each time.
Yeah, every time you do it. In fact, there's a way to open files in append mode, and
Oh, so you're just rewriting it completely?
I'm rewriting it completely every time. Every time I do this.
Append.
Why is that not? Why is that not working? What's going on here? Sorry.
If you're rewriting it on every time, how come the file name is changed?
I'm writing a new file. I'm not quite
It's a
sure.
new file, okay.
Yeah, I'm not quite sure what's going. Why one of my keys stopped working easy. But I guess I'll use cut and paste, which is a lot less fast. So it must have. Oh, I know what it is. Why does it do this sometimes? No, that's right. Let's try this again. Voila. Okay, good. So I just used the name. The name isn't really changing. I just used this name now. I could have used, any name I wanted here. I could have done this and then. Well, I'm gonna get lippy. So it writes it immediately. So you're absolutely right. It will write over your file and destroy it, no matter what it is, if you have permissions to write. You can't actually overwrite your system file or anything. No recourse. Nothing's backed up. Nothing goes to the trash. It's killed
So
instantaneously.
you have to be careful not to open a file name after you have something important.
Yeah. You don't want to name. You don't want to name. If you overwrite Microsoft Word or you overwrite something key to your operating system or whatever it is, it won't stop you. I mean, there's some things you won't have permissions to write to.
Really?
What? Oh yeah.
So you just kill your whole computer because you wrote a file and you made a typo or something?
So let me tell you a story here. I used to work at a huge investment bank, and many years ago, I'm ashamed to say I did this, but I got over it. There was a problem where this huge mainframe, which is, I don't know if you've ever heard of VAXes, many years ago, I'm sure you have, ancient computers now, but at the time they were the pride and joy of this company. There's this huge installation of these things, a cluster of these, and multiple times a day, it would go down. The whole system would go down, leaving hundreds of millions of dollars floating in the air, basically. People having to do things by pencil and paper. And they'd bring it from a backup, because all the disks would be erased in this driving thing. They'd bring it from a backup, and that took hours to bring from a backup. So they couldn't work it out, and DEC, who ran the company running computers, was justifiably very, very concerned. They flew out their #1 super expert on this, who had all of these literally hardware things that allowed him to look through the hardware on disks that had been supposedly erased and things. So he looked through, my boss told me this sitting there, and he said, well, we looked through the disk, the record, and that somebody had basically done a command that had deliberately written over the system partition. And typed from that terminal over there, as he told me, at 2 in the morning. So they said, and the system administrator had been having, some troubles with his wife and troubles at home and things. And so he didn't have to deal with the troubles with his wife because always in at work because the system was always crashing. So he wasn't even seeing her as a result. So they put 2 and 2 together, and they just called up and said, oh, we're having a meeting Monday morning to discuss the causes of the system crash, which should have been innocuous, and he never showed up again. He had been destroying the stuff himself by deliberately overwriting the system,
Because he was having problems with his wife?
Well, that's what we all deduced.
Yeah, that's fun.
That's what we all deduced, because it gave him an excuse not to be at home, right? Really...
He has to solve that problem.
Yeah, it was bad. Well, no, this guy on the internet, I won't say his name, he's got a very memorable name. And the worst is that this very young kid from, Drexel was pretty enlightened, and they hired all of these people who were from, you don't have to memorize any of this. They were all from Queen's College. They got all these young Orthodox kids from Queen's College, which is pretty hip for an investment bank, because mainly they only like, no, it's not the case, they only like WASP, to say the least, but they don't like people going to skanky colleges like Queen's College, But they got a couple, and then they got a bunch more, and they worked really well, and it was a nice thing about these guys that they were somewhat more into just pure skill than whether you went to an Ivy League. So this young kid who was maybe 22 got the job of this much older guy, system administrator, after he vanished. And he did an amazing job, but later he confided in me that not only had this guy borrowed $1,000 from him before he vanished, which is quite a bit of money back in the day, particularly this young kid. Then 2 months later, he used him as a reference. A reference. And I'm like, oh, it's one thing if you screwed over the company, but he'd screwed over this guy personally for $1,000. All right. So the moral of this thing is, you can do tremendous damage. Luckily, modern operating systems won't let you do this. They won't let you actually overwrite. In fact, it's even back in the day, the guy who did it had to go do special things in order to make it happen. You couldn't have just, he had to be an administrator and he had to actually do, like, put special flags on, I really do want to destroy all of the disks. so there we go. But it's absolutely true. You had a question, right? Long time ago before I started this rambling.
Yeah, I did.
Oh, you had a question too.
Well, I mean, you can still do that if you start messing around with stuff that mixes in shell commands. You can still definitely destroy your computer fairly easily.
Absolutely. Oh, in fact, the worst is,
But
again,
with wildcards, I mean, you have to.
it doesn't even have to be wildcards. There's a thing you see all the time. Again, not on the final examiners. Not that there is one. But actually, this is worth knowing. Is a lot of things nowadays do this installation where they say, do this, get this file, pipe it to your shell. Ruby is an example. That's how they recommend you install. It's a terrible, terrible idea. Whoever thought of this was just bone stupid. What can happen is your network can be interrupted. You get a partial command and you execute it. It can do any old crap. People have destroyed their systems doing it. So why people come up with this as a suggestion is beyond me. Baffling. There's many ways to kill things. We should get back onto this.
And I also wrote a stupid little program that does crap to a file if we want a lot. It's like a specimen to work on. Yeah, I don't know.
Oh, well, we'll pass it on here. Actually, that to me has got Russian roulette for the shell now, where you run this command, and basically it's the first time you get a shot, 1 in 6, it does something minor. It progresses up to things like destroying random files, overriding your root partition and everything. So, sorry, Nat.
You might have said this, where is nav.txt and libby.txt stored in like the file structure?
Oh, okay, that's a very good question. So, excellent question, I should have mentioned this. So, you notice that I call these things without a full path name. If you understand the idea of a full path, that tells you where on a disk your files are located. We're going to go back and we'll probably be dealing with this repeatedly, so I'm going to bring this in bit at a time. But suffice it to say that I actually started, let's actually quit Python here. Hello? I was in the wrong window. I quit Python here. I'm in this directory here, /users/Tom. I'm in some directory. You don't have to worry about where I am. But I'm just sitting in a folder. For the Mac users, I'm sitting in a folder which is my home folder. If I don't put anything for a file, you see that when I did the open here, when I did the open here, I just said open libby.txt. There's no path in front of it, just a file name. That occurs in the directory that Python is running in, the current directory. So it writes it. So Python always has this concept of the current directory. Just like the shell always has a concept of the current directory. Now I feel I probably should have brought all of that in before I started file writing. I hoped I could just sneak it by you, but nobody would ask that question. But, so let that sink in and I'll ask his question. I'll probably go back to it because I don't think that was a great explanation.
Is there a way to designate where you want the file?
Absolutely. Here's an example. Let's do something like this where I'm going to open, so /temp. /tmp happens to be a hidden but very useful directory that's on all Macintoshes and Unix machines. It's really handy because every time you reboot it's erased. So it's great to put crap in. That's what I do for all the time for tests. So I can do this here, and then if I go and say, here I'm going to do, and I can do /temp /libby. Well, and then you can see I put it somewhere else. So you just put what this is called, so this part here, this is called, what? Oh, sorry. This is called a full path because it starts with a slash. Anything that doesn't start with a slash is a relative path. Another name for this is an absolute path because it's an absolute address that works from wherever you are. Things like this without a slash, again called relative path. relative to where you are now. You could, if I said something like sub/lippy.txt, that would be a subdirectory of the directory I'm working in, the current working directory. We're going to do a little bit more of this later in the lesson. Did you have questions?
Yeah, what does the W mean again?
W means to write. It means open the file for writing. There's also another way to open a file, which I will do. Oops. There's another way to open a file where you say, I hope I got this right. Voila. That's opening for append. And so you can see that it just depends at the end of the file. So there are 3 ways to open a file. Read, write, and append. Now, actually, I'm lying to you about this. It turns out that because, unfortunately, of Windows, you could hear it coming. There's also 2 ways on top of this. This is writing, when you open a file like this with just A, W, or R, it's opened in text mode. What happens in text mode is basically it translates. Remember I told you that they have 2 characters from the end of line in Windows? When you open in text mode in Windows only, it translates those line endings into just 1 character, which is what you want, because otherwise life would be very miserable. There's another mode to open files for read, write, and append, where you add. Why does that keep happening? Baffling. Okay. Where you can say B. You add a B in there. That's binary mode. Binary mode means you want the file exactly as it's written. Please do not translate line endings. Right? And so on everything other than a Windows machine, that little B is relevant. And in fact, if you're only dealing with text files, you never want to put that B in. What happens though is you see that people will do things involving binary files, then somebody brings it to Windows. It works for a long time because they're doing it on binary files, and then one day they hit a binary file that has carriage return line feed in it. Accidentally, it doesn't mean carriage return line feed, it means two machine instructions, and it breaks. So unfortunately, it's just something you need to remember. If you're opening files that aren't text, you need to throw a tiny B in there somewhere. Question, Raymond?
Do other, like let's say it was, let's say I wanted to open an assembly file
Right.
in Python. Does that count as text?
Well, assembly is text file that's translated in the machine language.
Right.
So that would count as text. Anything you're actually typing into is text. Again, you don't need to worry about this course. For this course, everything we're going to be opening is, in fact, text files. But for those of you who are on Windows, you should bear in mind particularly that this is actually, it's more of a trap for people who aren't on Windows, because it won't work for you if you're on Windows immediately, you'll know. But if you aren't on Windows, stuff will work for you until some poor sap tries to run it on a Windows machine.
So I'm on Windows, so I always need to remember to put it in binary.
No. Quite the reverse is, if you're opening a text file, everything's fine. You don't need the binary thing. We're only going to be opening text files in this lesson.
Right.
Or in any of these lessons, so you won't have a problem. But just all of you need to remember when you're opening a binary file, like machine language,
I just
like
was opening up pure hex code.
pure hex code, or an image, for example. An image file is binary. It's like numbers. It's not actually text. So that's the one key thing to remember there. If you're opening something that's not pure text, and you're on Windows, you must put the B in. And unfortunately, it's one of those. This isn't a deficiency of Python. It's a deficiency of Windows, unfortunately. Right. Did I get everything to do? So we've got reading files, writing files, appending to files. I think that's pretty well it. Oh, and that's the other thing is a file. When you open a file for read, it is in fact an iterator. Let's just say, well, let's just do something. It becomes an iterator, which is rather nice. So if I have f equals open here, and let's open this for read. Wah. I put a space in the beginning of that. Thank you. Okay. So this is actually, if you remember iterators, Those are very, generators are one of the examples of iterators. Those ones you can get something from one at a time. And so I can get one line at a time from this file. I can go f.next, and I can do it again. Each one of these brings out a string. And then at the end, look, it throws a stop, oops. It throws a stop iteration. It gives me an error, a traceback stop iteration. That's kind of handy because you can, if you just want to look at the beginning of a file, you open it and then just do next a few times to look at the very beginning. Very convenient when you're dealing with a large file. You had a question, Rick? Oh no, distraction. Okay, good. And I think
Text open lines of text?
yes, it returns lines of text. And it's that ability to open lines of text is why there's a difference between read and read binary. And again, is only on, and that's only true, again, it has to do with Windows only. Everywhere else it's fine. It wouldn't really make a difference if you split your file up on carriage returns, even if it was a binary, because on Linux or the Mac or every other thing except Windows, it wouldn't make any difference at all because you're not changing the values. But on Windows, they not only split it, they remove that line feed because it's confusing. Right? So Windows has an extra line feed that gets removed. So that's why this little mess here. Very unfortunate. Not my responsibility. I didn't do it. Okay, so let's take a look here. Oh, the with statement, we're skipping that one because it's too boring. It'll be part of the cleanliness is next to godliness thing. All right, so now we're getting into the really exciting thing. This is the really great part, is the Python libraries. Now, one of the things I think I've emphasized about 37 times, but here's the 38th. The thing that makes it for Python is it has libraries to do absolutely everything you have ever come up with, probably. Anything that's general purpose, there is a library to do it. And there's a really, really nice system to use these libraries. All these libraries are sitting there potentially for you right now, but you have to just, there's a way to actually say, I want to use this library that's very, very simple. Life would not be much fun if all the libraries were there all the time. You'd be running into them with your other variables. It would be confusing. So there's a terribly simple statement. It's called the import statement. So we're going to say now, we're going to start off by saying import math. So what does this do? This creates a new variable called math. Look, we have something called math, and it says, this is all very complicated, but it says, it's actually not so unreasonable. It says this is a module. And a module is Python's name for libraries, they're called modules. And one of the very, very nice things about these modules is it's trivial to create your own module. Absolutely trivial. It's one of the very, very nice things about the language. Most of the languages creating a library, you have to do all this stuff. Here, nothing. Make files, put them in a directory, you're done, more or less. So it says this is a module, which is a collection of programs you can use. And this long thing here merely says actually where the source code for this is. And actually you can see that, you notice there's a thing at the end, it doesn't say .py. This is actually a module that's written in machine language. It's not written in Python. Yeah. But something has to be written, Python can't all be written in Python. Where would you go? Actually, I say this, but there is a version of Python that's entirely written in Python. Called PyPy. Pretty funny, right? Python. But they bootstrap it. They start off with somebody else's Python, they run the Python in there, and then that runs it. Right, so this is a math module. So what do we have here? We have, remember, you see me keep doing this classic directory and this sort of thing. Oh, I'm sorry, dir, math, let's try that properly. And you can see, so here's a help on this thing, and there's a huge number of these things, all stuff you might want to do, or you can just do, hope that's okay. And you can see, and these are a huge number of things you might want to do if you want to do mathematics. My theory is we won't use any one of these in this class. But you may want to do, if you want to do things like exponentials or the, hyperbolic arctangent, yes?
We're probably using random, right?
That's very, very true. But random is a separate directory, separate module.
Yeah, I haven't found that. Where
It is a Python module.
Oh yes, certainly. It goes. Come on. Okay. In fact, who's got the stick? I'm being bad about this. So guess, we want to do random things. Guess what I'm going to type here.
Import random.
Got it in one. Right? Easy enough. And so we can say, and random has all your random needs here. And it turns out that there's some particularly easy ones. Yeah. And some of these, it's very interesting. They've gone to a lot of work. It uses a Mersenne, the randomizer is a Mersenne twister. Mersenne's a French mathematician from the 18th century who did a lot of work with primes. And you don't need to know anything about it if it's a really good random number generator very fast. And you don't really need to know anything about any of these. You can probably get away with 2 of these. I usually, 99 times out of 100, I use 1 of these, which is the following. Let's pick a list and we'll call it T equals a, let's make it a string. T equals these things. Right, so I can do random.choice T. Simple enough. It picks a random item. Why does it, for some reason, something about this is keeps. Well, I'll just type it in again. Right? Every time I do this, there we go. Oh, why is that? I don't understand what's going on there, but who cares? Voila. So, oh, I understand. I'm in the wrong window here. Let me go. We'll stay in this window. Sorry about that. I had a mode error in my mind went blank. Sorry.
If I opened the help for one of these, how do I exit that?
Spacebar. Not working. Q.
It's probably piping into left, suggesting.
Something like that. Oh, Q. Escape. Try any of those. Oh, escape. Let me try here.
Q works.
Q works. Okay. Q. Sorry about that. I should have just tried it out there. So you can see that random.choice every time picks a random item from T, and T can be any indexable item. But I believe, let's just find this out. I think that you can actually have it be any iterator. So let's try it out. Let's try X range. Remember, so for bonus points here, who remembers seeing X range in range?
I couldn't make out the difference, honestly.
Okay. What's this? Yes, okay, so, well, let's take a look. Let me just quickly go back and show you this to you. So here we go. Range 10, who's got the stick? What's that going to do? Question. This is a question, not a guess.
List 0 to 10.
Right. Absolutely. Now, right, what? I told you were right, so there we go. So, passing on. So who remembers what X range does? Do you remember? Okay, so X range returns X range 10. Not very interesting. But what it is it is a generator. You see that X range actually creates this huge list. If I do, range creates that huge list. If I do range, like some very long number, it won't let me do it. But X range is an iterator. It doesn't store all those. All it does is have the ability to chuck out a value when it's asked. So I can say X range here, this, and it'll work perfectly well. And I can start iterating over it. So I can say that's probably a bit long. But I can say for I in X range 10. Oh, well. So it has the same effect as a range, but it doesn't actually construct all the values. So it's more efficient to use X range when you can. That said, don't bother. Again, the efficiency is tiny, you'll never notice it. But the reason I'm using it now is to test what happens. Let's just actually see if choice actually works. If I do X range, we'll find out, won't we? So who wants to guess? I don't even know for sure what's going to happen here. What if 2 things are going to happen, though? I can tell you. It's either going to pick a random number from 0 to 9, or it's going to give me an error. Anyone want to guess?
It's gonna pick a random number.
Yeah, okay, we'll find out. Let's just find out. It picked a random number. Very clever.
Isn't that essentially the same thing as doing like rand int open parentheses like 1 or 0, 10?
What do do you mean?
int.
Well, int is a type, remember, so I can't really do that, right? That's going to give it. About this.
Randint is like a.
Oh, that's true. Yes, it is something. It is something much like that. Well, it's true, but it has to know somehow that that's it probably is. I don't know how. I'll work out exactly how.
But that wouldn't be a generator, right? Technically, if I was using randint.
No.
And then
You
this
can
is.
make it into a generator.
Right, but this is a generator.
X range is a generator.
Okay.
Right. Sorry. Question here.
When would this be useful, the random choice? When would it?
Very good question. For one thing, we ourselves are going to be using it for text mangling. Often, in the real world, why would you use random? There are a bunch of reasons to use random. Sometimes, for example, you need to drop things into some big area, and you just need to make sure that they don't that they just spread out. You don't want them all clumped together. For those reasons. You use randomization. Another reason is a classic thing called dithering. When you're, it turns out that when you actually do things involving drawing pixels on a screen, sometimes you get this thing called aliasing. And that's also true when you're making audio samples to your speakers. What happens is, because of the fact you have to digitize everything, you have to round everything off to the nearest integer, you get these phantom straight lines appearing that don't actually exist. They're an artifact of the rounding off process. So you do this dithering where you add you take the least bit and you add a random 0 or 1 to that bit at random. And paradoxically enough, you add a small amount of random noise, it makes your picture come clearer. And the same in audio as well, you do dithering to actually make your picture. So you actually use a bit of randomness, and what it does is it smooths out these artifacts of your computation. That's another reason for random. And then of course there's tons of things involving statistics, random sampling, but mainly I have to say that I use randomization all the time for art purposes. It's the best way, you say, okay, I have this sequence of things, now I want to jumble it all up. I want to play in a random order. I just want to screw all the verbs now. I'm going to jumble all the verbs in the noun. So I do it for music. Okay, I have this sequence now. I want to say, let's pick 5 parts of this at random. And it's really nice. It's a great creativity tool. A lot of fun. So yes.
And it's also useful for game design.
Oh, and very much for games. Yes, of course. Double, right? Every game has randomization. Has to. Otherwise, it plays exactly the same way. Not every game. Pac-Man is completely fixed.
Right.
That's why people can play the game blind. Literally, people can play Pac-Man blindfolded. What a good use of your time, I think. Okay, I think we should take a quick break here because and then we'll go back and do like another 20 minutes.
Yes.